Should I use RAID for backup? No. Hi everyone, I'm Leo Notenboom for askleo.com. Ask Leo is supported in large part by its patrons. If you're interested in an ad-free experience on askleo.com or access to exclusive patron-only content, visit askleo.com/patron for more information. Yes, the answer kind of snuck out there. No, you should not use RAID for backup. Here's the question. Do you think RAID is a valuable alternative for backing up? The answer is no. No, it just is not. I want to review what RAID is and, more importantly, what it is not. RAID is an acronym for Redundant Array of Inexpensive Disks or Drives. Using RAID technology, multiple disks are combined in various ways to act or behave as if they were a single disk. There are several ways that they can be arranged, but there are typically two reasons for doing or using RAID. One is reliability and the other is speed. Those two, sometimes combined, are the goal of having what's called a RAID array. So, reliability. RAID 1, which is what the question was actually asking about, uses what's called mirroring to improve the reliability, or more correctly, the fault tolerance of a disk drive. What happens is the two drives appear as if they are one. When you write something, it gets written to both drives. The reason that RAID 1 gives you reliability is that either of those drives can fail. In fact, they can fail completely, and your system will keep working because everything continues to be stored on the other drive. It is not a backup, but it is a redundant copy, a live redundant copy of everything you're working on. Many hardware RAID controllers actually allow you to replace the failed drive without turning it off, so that you can basically keep running as if nothing happened. Once the replacement drive is installed, the RAID controller takes care of updating it with all of the data that's on the working drive, and then continues to write all the data to both as it arrives. That's reliability. Throughout all of this, that one logical drive, your C drive, for example, just continues to work. RAID is also improved speed. So RAID 0 uses what's called striping to increase the apparent speed of your disk. What that means is that rather than writing your data on one disk, it spreads it out across two disks. So half of your data is written on one disk and half of your data is written on another. That sounds kind of nifty because what happens is when you read the data, it can actually be read twice as fast. It can start reading the first half of the data and the second half of the data at the same time so that it arrives more quickly to your computer's CPU. The downside is that you've doubled your chance of failure. If either disk fails, you've now lost all of the data on both. There's no way to recover the data on a failed drive if you're using something like RAID 0. That's why RAID 0, honestly, should never be used. It still is from time to time, and I've even seen systems come that way, but it should never be used unless you've got yourself one heck of a backup strategy, because like I said, you've got two disks, two chances for failure, either of which will cause the entire disk to be lost. Now, we can move on from RAID 0 and RAID 1 into various combinations which have various numbers, and I'm not going to try and lay out all the different RAID combinations. But if we take the two concepts that we've just talked about, writing the data redundantly on two different drives and spreading the data across two different drives, if we combine those, we actually can get the best of both worlds. So if we take three drives, I'll call them A and B and Z. When data is written to this trio of drives, A, B, and Z, A and B are treated kind of like RAID 1. In other words, they both get a copy of the data. But at the same time, a calculation is performed. It's called a checksum, but you can think of it as a simple sum of just the data that's written to A plus the data that's written to B is what's then written to drive Z, the third drive in this trio. So what does that mean? Well, it means that either of those drives, in fact, any of those drives can fail and everything is recoverable. If drive A fails, well, you recalculate it by Z minus B. If drive B fails, well, you recalculate what was on it by Z minus A. And of course, if drive Z fails, well, you recalculate it as everything on A plus everything on B. That's oversimplified, of course, but the idea is that any one of those drives can fail, can be replaced without any data loss. And on top of that, the data is spread out across those two drives. It's not duplicated, it's spread out across those two drives, which means it actually gets faster. The reads to that drive or even the writes to that drive can often be significantly faster than writing to a simple drive. This concept typically gets expanded beyond 3 drives, sometimes as many as 5 or 7 or even more, but the idea is the same. Data is spread across some number of drives, and then there is an additional drive or drives that contain a calculation that allows some combination of the data to be recovered should any of the drives fail. So all of this is well and good, and it kind of explains why RAID exists. Again, redundancy so that hardware can fail without data loss, and speed so that you have multiple drives sharing the load, reading off of it faster. It's not a backup. It's still not a backup. The data is in only one place. It's in the RAID array. If the RAID controller, which is a single point of failure in this scenario, happens to die, and it definitely happens, you've once again lost all of your data. And in fact, because the disks are behind a RAID controller, it's usually the case that the data can't even be recovered off the drives because they're in a proprietary format unique to that specific RAID controller. So you still need to back up. RAID is great for redundancy, for reliability, for performance, but it is not a substitute for backup. And finally, one last thing I want to point out about RAID. RAID was developed and is at its best when the drives you're talking about are running spinning magnetic hard disk platters. They are the ones that have speed issues relating to where the data might be stored on the drive. They're slower than SSDs. While technically you could use an array of SSDs as in a RAID array, it's typically not done. Typically, RAID arrays are really all about spinning magnetic disks. RAID is great what it's good for, it's just not good for backups. If this kind of information is useful to you, if you find it interesting, you may consider signing up for my weekly Confident Computing email newsletter. Visit askleo.com/newsletter for more information. For links, for updates, for comments, and more related to this article, visit askleo.com/4372. I'm Leo Notenboom. This is askleo.com. Thanks for watching.